Welcome back to Breakthrough Beat, the podcast where we unpack the wildest, most mind-bending discoveries in science and tech for you, the curious folks out there. I'm your host, Mia Carter, and today we've got something truly out of this world to dive into. Joining me is none other than Dr. Elias Voss, one of the planet's top quantum physicists and a total rock star in the lab. Elias, thanks for being here.
Hey Mia, always a blast to chat with you and your listeners. And trust me, this one's a doozy. I'm still geeking out about it myself.
Oh, I can tell. So folks, here's the headline that's got us buzzing. Scientists, led by a team at Rutgers University, have smashed together two impossible materials to create a brand new artificial structure. They're calling it a quantum sandwich, and it might just unlock secrets for the future of quantum computing. Elias, break it down for us. What's the big deal here?
Alright, picture this. You've got two materials that, on their own, are already so weird they make quantum physicists like me scratch our heads. One's called dysprosium titanate. Think of it as this funky spin ice that traps tiny magnetic oddballs called monopoles. The other's pyrochlore iridate, a semi-metal packed with these zippy little particles called wild fermions that act like they're straight out of a sci-fi movie. Individually, they're wild. Together, it's like a cosmic peanut butter and jelly sandwich, except it's on the atomic scale and could change tech as we know it.
Okay, hold up. Monopoles? Wild fermions? You're losing me a bit here, Elias. Let's make this relatable for our listeners. What are these things, and why do they matter to someone who's, say, just trying to get through their day?
Fair point, Mia. Let's simplify. Imagine a regular magnet. You've got a north pole and a south pole, right? A magnetic monopole is like a magnet with just one pole. Sounds impossible, and in nature it kind of is, except inside this spin ice material, where quantum rules let these lone poles pop up. It's like finding a unicorn in your backyard. Then, on the other side of the sandwich, whale fermions are these super light, super fast particles that zoom around like tiny beams of light. They're tough, they don't break down easily, and they could make electronics insanely efficient.
Unicorns and light beams. Now I'm picturing a quantum party in my head. So why mash these two together? What's the goal?
Great question. The magic happens where these two materials meet, what scientists call the interface. By layering them just right, atom by atom, the Rutgers team created this tiny sandwich that's only visible under crazy powerful microscopes. That interface is like a playground for quantum weirdness. They're hoping it'll reveal new tricks about how quantum stuff behaves. Tricks we could use to build things like quantum computers or super-sensitive sensors.
Oh, quantum computers. I've heard that term thrown around a lot. Give us the elevator pitch. Why should we care about them?
Imagine a computer that doesn't just chug along one calculation at a time like your laptop. Instead, it uses quantum bits, or qubits, that can be in multiple states at once. It's like flipping a coin that's heads and tails until you look at it. That superpower, called superposition, means quantum computers could solve problems, like cracking complex codes or designing life-saving drugs, in hours instead of centuries. This sandwich could help us figure out how to make those qubits more stable and practical.
Whoa, centuries to hours? That's a game changer. So how did they even pull this off? I mean, it sounds like sci-fi wizardry.
It's close! The team, led by Professor Jack Chakalian at Rutgers, spent 4 years tinkering. These materials are so finicky that they had to invent a whole new gadget called the Q-DIP, Quantum Phenomena Discovery Platform. It's got lasers, one to heat stuff up, another to stack atoms like Lego bricks, all while keeping everything near absolute zero, the coldest temperature possible. It's like cooking a gourmet meal in a freezer with a laser spatula.
Laser spatulas. I'm stealing that from my kitchen. I love that it's not just the bigwigs either. Students like Michael Turilli, Sung-Chi Wu, and Dorothy Dowdy were in on this too, right?
Totally. That's what I love about science. It's a team sport. Those students, plus folks like Mikhail Kareev and Fangdi Wen, were key to cracking this puzzle. It's inspiring to see the next generation already pushing boundaries.
So what's next? Are we all getting quantum gadgets for Christmas?
Laughs. Not quite yet, Mia. This is a huge step, but it's still early days. They'll study this sandwich to see what secrets it spills. Maybe new ways to build quantum sensors or spintronic devices, which use electron spin for tech. Down the road, it could mean faster computers, better AI, or even breakthroughs in medicine. But for now, it's about exploring the unknown.
Exploring the unknown. Sounds like a perfect note to end on. Elias, thanks for making our brains tingle with this one. Folks, if you want more science that feels like magic, subscribe to Breakthrough Beat, and maybe check out phys.org's newsletter while you're at it. Until next time, keep wondering.
Thanks, Mia. Catch you later.